1.8 about absolute value equations and inequalities has some special cases that we need to talk about. If you remember what we talked about with absolute value equations, we said that absolute value means how far away something is from zero on a number line. So, given that absolute value means how far away from zero, what comes out of absolute value should always be either zero or a positive number. So anytime I have the absolute value of anything, that should give us a number that is either zero or larger. So if I'm telling you that absolute value is equal to a negative number, that cannot happen because the absolute value of anything should give us something that is zero or larger. So that's no solution. Similarly, absolute value can't be less than or equal to a negative number, and it can't be less than zero because it has to be zero or larger. If I have absolute value is greater than zero, then that would be all real numbers except for the single value that gives me equal zero. So that would be all real numbers except one number. I'm only going to have one solution if it says absolute value equals zero or absolute value is less than or equal to zero. And then my solution is going to be all real numbers if I say absolute value is greater than or equal to zero, because absolute value of anything should be zero or larger. Similarly, if I have absolute value is greater than or equal to a negative or just greater than a negative. So these are our special cases, and let's look at some examples that show us those special cases. We have absolute value of 2 minus 5x is greater than or equal to negative 4. So because absolute value is always going to be larger than negative 4, the solution to this is going to be all real numbers, negative infinity to infinity. If we solved it, if we were to solve it, like we shouldn't because it's a special case, but let me show you what would happen if you forgot that it was a special case and you went ahead and solved it anyway. We would replace our inequality with an equal sign, and then we would write two equations, 2 minus 5x equals negative 4, 2 minus 5x equals 4. When we solve those, we get negative 5x equals negative 6. By the way, I would not write this stuff down if it were me. So x equals 6/5. And then negative 5x equals 2. So x equals negative 2/5. So if I put those on a number line, then I would have my negative 2/5 and 6/5. They would both be closed because the original one was an equal to, like a greater than or equal to. 6/5, oh, I don't even need to know how much it equals really because this is negative and this is positive. So I need a number in between negative infinity and negative 2/5 with a bracket. So how about like negative 1? So that's absolute value of 2 minus 5 times negative 1 is greater than or equal to negative 4. 5 times negative 1 is 5. 2 minus 5 is negative 3. Absolute value of negative 3 is 3. Is 3 bigger than negative 4? Yes. So this is part of my solution. And it's colored in. Then something between negative 2/5 and 6/5. 0. So that's going to be absolute value of 2 minus 0 is bigger than negative 4. Absolute value of 2 is 2, and that is true. So this is part of my solution. And that's the interval that includes negative 2/5 and goes to 6/5. And then my other interval includes 6/5, goes to infinity. If I picked like 5 in there. So I got absolute value of 2 minus 25. Is that bigger than negative 4? That's absolute value of negative 21, which is 21, and that is also true. So I have now colored the entire number line because of those closed circles. So it goes negative infinity all the way to infinity. So this answer is negative infinity to infinity. What about this one? Absolute value of 4x minus 7 is less than negative 3. Well, this absolute value is always going to be a number that is 0 or larger. So a number that is 0 or larger is never going to be smaller than negative 3. So this doesn't ever work. This will never be true. So when the answer, like when the thing is never true, then there's no solution. So this would be either the empty set or no solution. How about absolute value of 5x plus 15 equals 0? Well, this actually can be true because the absolute value of anything is going to be 0 or larger. So when I go to set up my two equations, I have 5x plus 15 equals 0 or 5x plus 15 equals negative 0. Well, this one doesn't even make sense. There's no such thing as negative 0. So we don't even have to worry about this equation. We only have the one equation here. So I'll solve that by subtracting 15 from both sides. It's a little weird looking. So 5x equals negative 15, which means that x would equal negative 3. That is the only solution to this equation. If you have absolute value equals 0, you're only going to have one answer, and it's x equals whatever number you got. How about 7x plus 9 is greater than 0? So in this case, we rewrite as an equation, and then we would write our two equations. But remember, when we have absolute value equals 0, this other equation doesn't make sense because it would say equals negative 0. So we just have the one equation. 7x equals negative 9 leads us to x equals negative 9/7. It's an inequality, so I'm going to go ahead and make my number line, but I'm only putting one value on it, negative 9/7, because that's the only critical value I got. It's going to have an open circle, so I'm going to test a value in the interval from negative infinity to negative 9/7, and then I'm going to test a value in the interval from negative 9/7 to infinity. So let's pick a number over here, like maybe negative 10. That gives me absolute value of negative 70 plus 9. Is that bigger than 0? Well, of course it is. The absolute value of any number is bigger than 0. So this is true. Then pick a number over here between negative 9/7 and infinity. How about 0? So that's absolute value of 0 plus 9 is greater than 0. Well, that is also true because the absolute value of any number is bigger than 0. So I have this interval up here that goes from negative infinity to negative 9/7, and I have this interval here that goes from negative 9/7 to infinity. But negative 9/7 is an open circle. So my solution has to have those two intervals, but I have to skip over that value of negative 9/7 and give my answer as the union of these two intervals. We can use absolute values to model distance and tolerance. To find the difference between two values, we can use absolute value, and then that way the order we subtract doesn't matter. So if I have two locations on the number line, and I just want to know the distance between the two, I can subtract A minus B, or I can subtract B minus A, and it won't matter. So if I want to know how far is it from 127 to 53, I can either do the absolute value of 53 minus 127 or the absolute value of 127 minus 53. Either way, that's going to give me the same value. And gosh, if I had a calculator, I could probably tell you that a lot faster. 127 minus 53, that is 4. 12 minus 5 is 7. So this would be absolute value of negative 74, which is the same as the absolute value of positive 74, which is just 74. So we're going to use this to write statements showing that something like K is no less than 5 units from 8. So I'm wanting to know the distance between K and 8. So on a number line, the distance between K and 8. So I have choices. I can say the absolute value of K minus 8, or I can say the absolute value of 8 minus K. Either way, I want that distance to be no less than 5 units. So it could be 5 units, or it could be more than 5 units. So I want it to be no less than 5 units. So equal to or bigger than 5 units. So either way, I have K minus 8 in absolute value is greater than or equal to 5, or absolute value of 8 minus K is greater than or equal to 5. Either one of those is going to give me the correct expression to represent that sentence. Okay, let's look at this one. N is within 0.001 units of 6. So I'm looking at the difference between N and 6 on a number line. So N to 6, that distance would either be absolute value of N minus 6 or absolute value of 6 minus N. Either way, I want it to be within 0.001. So I want this to be smaller than 0.001. So that will be a less than. So either of those would represent N being within 0.001 of 6. Okay, we can also use this to model tolerance. In quality control situations, such as filling bottles on an assembly line, we often wish to keep the difference between two quantities within some predetermined amount called the tolerance. So suppose we want suppose y is equal to 2x plus 1, and we want y to be within 0.01 units of 4. So this is the same kind of thing as asking the distance between the two things to be smaller than something. So I have y and I have 4. And I want the difference between them to be within 0.01 units. So I would want to either say absolute value of y minus 4 is less than 0.01, or absolute value of 4 minus y is less than 0.01. But I know that y is equal to 2x plus 1. So in order to find for what values of x will this be true, then I'm just going to replace y with 2x plus 1. The only time that's going to get tricky is when we have subtraction. So when I do this replacement, I'm going to say 2x plus 1 in parentheses, like that, which would give me 2x plus 1 minus 4 is less than 0.01. And then 2x minus 3 is less than 0.01. But if I do it this way with 4 minus absolute value of y, 4 minus y, we definitely need to put the 2x plus 1 in parentheses because then we distribute that subtraction. So that would be 4 minus 2x minus 1 less than 0.01, which is 3 minus 2x in absolute value is less than 0.01. To solve this inequality, we would replace the inequality with an equal sign and then get those critical values, put them on a number line. So I would choose one of these. I would rather do 2x minus 3. So absolute value of 2x minus 3 equals 0.01, which would give me two equations. 2x minus 3 equals 0.01. 2x minus 3 equals negative 0.01. Solving each of these, I get 2x equals 3.01 or 2x equals 2.99. Divide both sides by 2. I get x equals 1.505 or x equals 1.495. Next thing I need to do is make a number line with those values on it. So I have 1.495 and 1.505. My original inequality was less than, so we're going to have open circles. And then I'm going to test values in the original inequality here, not here, because that doesn't have any x's. These are x's. So if I pick like x equals 0, maybe, x equals 1.5, and maybe x equals 2. So I'm going to do 2 times x plus 1. 2 times 0 plus 1 is 1. Minus 4. Is that less than 0.01? Well, that's 1 minus 4 is negative 3. Absolute value of that is 3. So 3 is less than 0.01. That does not work. 1.5. So I got 2 times 1.5, which is 3. 3 plus 1 is 4. So 4 minus 4, is that less than 0.01? Well, that is 0. So yes, that is true. So here is a section that's a solution. And then if x is 2, I have absolute value of 2 times 2, which is 4. 4 plus 1 is 5. So absolute value of 5 minus 4, which is 1. Is 1 less than 0.01? No. So in this case, the solution would be that x needs to be between 1.495 and 1.505, or the interval from 1.495 to 1.505. So we would have to make sure that on our assembly line, this is the amount of wiggle room we are allowed to have in x so that y is within 0.01 units of 4.